Great. Welcome. As I've said, we're going to give you a bit of a talk today. What we're going to do is I'm going to first introduce the energy sector and why we're shifting to smarter operation. I'm then going to give a really short overview of the MSC. Then I'm going to hand over to David, and he's going to tell us about some really exciting developments and opportunities in the sector. We between us will speak for around about 30 minutes, perhaps a little bit more. And then after that, we'll open the session to discussion and questions, and you can put your questions and comments in the Q&A. And at that point, we'll also be bringing in Hallie and Varun to give their perspectives too. So let's make a start. So UCL Energy Institute is part of the Bartlett Faculty of the Built Environment, and it's just been announced today that the Bartlett has once again been ranked #1 in the world for built environment studies. That's 4 years in a row, and something that we're very proud of. The Energy Institute aims to deliver world-leading research, learning, and policy support. We're all about doing something about climate change, energy security, and energy affordability. We focus on excellence in everything that we do, as you'd expect, but also on being innovative. So trying to bring new perspectives to the challenges that we face. Perhaps unlike some of you from your previous institutions, one of our main focuses is on impact. We are here to do something about the challenges that we face, and that's something that we definitely carry forward into the course. We're also a really diverse community where everybody should feel valued and respected. The research themes within the Institute, we've got 6 of them, and within those, a whole load of smaller research groups. And these address the key challenges that we face around decarbonisation and climate change. David and I both sit in the energy and buildings area, but we work closely with those from other sectors and to provide really diverse interests and perspectives. I'm sure you're all aware of climate change and how it really is a global problem. Everybody's impacted, and we're seeing those impacts in terms of wildfires, overheating, flooding, and more. The energy system, therefore, needs to decarbonise. And we're starting to see really large changes in the energy system, and I'll be talking about that a bit more in a few moments. And whilst at times we might feel like the commitment to doing something about climate change isn't as strong as it could be, when you look at the rate of change of the system, in most countries, it really is profound how fast the energy system is changing. So most of the world is accepting that this is happening and the change is moving forwards. And in any case, the solutions ahead, as I'm going to show you, are more cost effective than alternatives. So it's a really exciting time to be in this area, and it's a really fast developing area. And David's going to highlight some of the recent changes in the sector. So apart from climate change, we consider primarily 3 other really big priorities, being energy security, affordability and equity, and having healthy buildings that are good for our well-being. Energy security is obviously in the news a lot at the moment, but reliable energy supply underpins stability and growth. It's essential for all aspects of modern worlds. And as demand rises, which it will do, we need to provide for that increased demand and address new vulnerabilities and opportunities. So we have this challenge of how do we ensure security of supply as we're decarbonising. So lots of change all at once, which is a big challenge. When it comes to affordability and equity, one of the biggest problems is that high energy costs put disproportionate burden on low income households, but also energy prices are absolutely central to competitiveness for buildings. So we need to think about solutions that can reduce costs and be equitable so everybody can afford energy supply. Finally, but by no means least, we absolutely depend upon our built environment to provide healthy and productive environments. The health risks of poor indoor air quality range across cardiovascular issues from heart disease and heart attacks, cancers, and a wide range of other issues. And it really is essential to our everyday life that our buildings are healthy, pleasant places to be. We've got to do this as we change the energy system and as the climate changes. And of course, that change in climate changes what it's like to be indoors. In some countries, that means it will be much hotter indoors. And how do we deal with that? In other places, we might find that regulations could come in that change the internal environment. And those could be for the worse unless we prepare for them and we account for them. How's energy used at the moment? Well, energy is used uh, mostly within buildings. And we can see that here. And I don't know if you can see my pointer, but don't worry, you don't need to. Oh, there you go. You can see my pointer. So we can see that residential buildings are really quite a large proportion of total energy demand. But these other sectors, services, that's mostly coming through buildings. Manufacturing happens in buildings, and transport, as we decarbonize transport through electric vehicles, those are plugged in at buildings and often plugged in to the same supply. So as we decarbonize and we electrify heating, cooling is obviously electrified already, we see this huge potential increase in demand and a really real shift of the way the energy system works at the moment. And supply kind of feels like an easy win, and it's the thing that you'll see in the news a lot, where at the moment we're dominated by fossil fuels, although it's changing quite fast. Fossil fuels are absolutely brilliant for generation because they've got storage built within them. And if you want to match to demand, you can just burn a bit more or a bit less. So it's really flexible, really easy to handle, but it's also really bad for the environment and we can't continue to do it. So what do we do going forwards? Well, we're looking at a much more diverse system, so many more different sources. And we're seeing large contributions from renewables, so wind, hydro, solar, and so on. We might also see quite large contributions from things like nuclear or fossil fuels with carbon capture, usage and storage. And the key feature about all of this future system is that it's much less flexible. So if we can no longer easily flex supply up and down, how do we match supply and demand? And there's a very simple summary. Here we see that decarbonisation is required, but also we're going to grow economically and we've got a bigger population. Buildings is a really big part of the total, and much of that goes for heating and cooling, which ends up being a focus for us. As we decarbonise and we're getting that demand to move over to electricity, much higher electricity demand. So not only are we shifting current generation from relatively flexible fossil fuels, which are bad for the environment, we are also massively increasing the amount of generation at the same time. What can we do? Well, we can install very large quantities of generation and then just turn it off when we don't need it. This is really bad for business. This is wasting energy. We could reduce the security of supply. So we just turn off somebody's power. That's unpopular and it's bad for the economy and it's bad for health and well-being. We might have greater interconnection, and that's something that we talk about on the MSc and how interconnection helps us. But also, we could start to manage demand to match supply, and we can start to store energy in new ways. And these are core components of what we call a smart or smarter energy system. And these are expected by most of the sector, the vast majority of the sector, to be absolutely essential moving forwards to match supply and demand to keep our electricity and energy system working in a decarbonised future at lowest cost. There are other ways to do it, but they tend to cost a lot more. So I've just talked to this, but just to highlight that smart energy being changing demand and storage as well or instead of generation. And that this is actually a revolution in the way that we work. This is not how the energy system has worked historically. And that means that we need lots of investment to make it work well. We need new businesses and new business models, and it brings with it huge challenges and opportunities. That as well means that it's a great place to come and study because the careers in the sector are really starting to take off, and it's a place where you can make a difference. Let me tell you a bit about the MSc. So we set up the MSc around 4 key principles. They're to be absolutely up to date with leading research. That helps us identify the latest challenges, the latest opportunities, and you can get involved with that during your time with us through your dissertation and through learning in the modules. We also set it up to be multidisciplinary, and that's because you need to understand different perspectives to deliver the solutions that are required for society. You'll learn from and with others, so you'll be part of quite a diverse cohort, and that will, alongside the set learning, help you understand both the physical side of the challenge, but also the social side and the need to bring them together. MSCs are all about getting a job, so we focused on skills. And so we've looked at the skills that employers need, like modelling, data analysis, coding, but also their soft skills such as writing, presenting, and time management. And we've made sure that they're part of the programme. And finally, we want to help our students and then graduates expand their networks. So to learn from industry, to learn about different roles and understand them, but also to start to collaborate and potentially to try and find a job. The programme, in summary, looks a little bit like this. I'm not going to go into it in detail, but in term 1, we've got 4 core modules that everybody does, although if you're part-time, you'll do 2 in the first year, 2 in the second year. In term 2, you've got 1 core module, and then you can choose from a wide range of options. And then in term 3, focus on the dissertation. You can see from the module titles the kind of approach that we take. So we've got fundamentals, which is really trying to bring the whole MSc together. And that takes mainly a physical and a policy approach. We've got society and social issues. We're looking at smart energy data, statistics, Internet of Things, and modelling. In term 2, Smart Distributed Energy Technologies aims to bring together the modules from term 1 and to really help students understand the technologies behind it, because the technologies and how they interact with the people are essential to understand what the opportunities and challenges might be. In terms of the optional modules we promote 4, which are the 4 here, which complement the rest of the course really well, but I'll say a bit more about other options in a moment. In term 3, it's dissertation time. One of the key things for us is that it's important for us that you can tailor your MSc. You do need a strong common foundation. You need shared understanding. You need to understand core physical principles and social principles and core knowledge. So everybody does those through the core modules. But then we wanted to create a series of flexible pathways so that you can develop your own specialism and interests. And so we've got 10 different optional modules that you choose 3 from. And they cover a really wide range of different things from developing countries, more modeling and data analytics, with things like machine learning in there. We've got thinking about businesses from different perspectives and social issues and more in there. Finally, the dissertation really is what many of our students say is the most exciting and enjoyable part of their time with us. So this is an opportunity to work with our researchers that are leading in their areas and to do something really exciting and interesting and hopefully impactful. It's also a really great opportunity to develop skills and to think about what job you'd like and what skills you might like for that. As I've said, we're interdisciplinary. And what's important here is that we don't aim to bring in engineers and physicists and mathematicians and so on and turn them into social scientists. We don't aim to bring in social scientists and business people and accountants and so on and turn them into engineers and physicists. What we aim to do is to ensure everybody has a common understanding of the sector and what's important, and to build on that so that we can all understand each other, appreciate the different aspects, and then collaborate together to find meaningful solutions. So that's what we try to do with the course. I always say as well, an MSc is a vocational degree. Its purpose is to help you get a good job. So not only do you learn the things that I've mentioned, so really important work skills, but we also aim to increase your understanding of the sector. So we have things like an industry seminar series where you can hear from people from industry come in, give a talk about their role. Sometimes they're recent graduates, sometimes they're just in a really interesting role, and they'll tell you about their job, and great for making contacts. We're still hearing, by the way, that from our graduates that there is a really good jobs market in this sector. So it is still a good place to come. Who should apply? We take applicants from a really wide range of different backgrounds. I've just said it's interdisciplinary, so that's what we're looking for, a really wide range from 2-2 up to first. And we're looking to bring in physical sciences, engineering, maths, geography, social sciences, all sorts, architecture, economics. So the key thing is that you should be interested and enthusiastic. That's really what we're looking for. If you'd like more information, there are a couple of places to look, and we're going to put this up again at the end, so there's no rush to scan these now if you don't have time. But that's to say that you can search for us, of course, but these QR codes take you to our web pages, to an animation overview of the MSc, and we've just had a video made with some graduate stories, which include Varun, who's with us today. So that's just been published, and you can see that through this link. With that, I'm going to hand over to David.
Great. Thanks, Cliff. Okay, so I'm going to kind of walk you through some of the work that I'm doing at the moment, which is feeding directly into both the modules that I teach and the dissertations I supervise. So just to give you a bit of context, so I teach the Society and the Energy System core module, and I also teach the New Energy Business Models elective module on the course. And of course, like all staff, I supervise dissertations as part of this. So what I'm going to show you is really a kind of an update on where the world is at the moment and the kind of work we're doing to make sure that people who come on our course are absolutely at the kind of front edge of what's happening in terms of the development of energy in the built environment. As this quote says here, I mean, we are in a unique position. It's kind of exciting and it's kind of scary at the same time, but everything is changing incredibly rapidly at the moment in this sector. You'll all be aware of data centers and how rapidly we're trying to build new data centers to build out more AI capacity. So we're involved literally at the moment preparing work for the Greater London Authority on where they can build data centres around London. The team, myself and Pamela and colleagues, are kind of working on how we can help startups identify places around London where they can actually create the capacity to build new data centres. And that links to a lot of work we're doing around the applications of AI in this sector. So it's super exciting, but yeah, it's super fast moving as well. Thanks, Cliff. Next slide. So this is what a new power station looks like. This is actually the engine room of what we now call a virtual power plant. And what you're looking at on the right-hand side is a module attached to the side of a house, which has a whole series of batteries for storing electricity and is wired in through that big cable into a solar panel on the roof. And it will coordinate how a heat pump works, and it will link to the electricity network. And what you're seeing on the left is a company called Luna, which has just come out of stealth mode. So they've just raised over $250 million to develop these systems. The guy who heads this up was ex-Tesla engineer who has spun out this company, and they design and build their own stacks that you're seeing on the right, and they install them in homes all over the world, starting at the American market. And they are then linking all these together using AI and smart controls to be able to create and manage energy across urban systems. Next slide, next, Cliff. So the interesting thing with Luna, it's a Silicon Valley startup. So it jumped out of Tesla, as I was saying. But in order to make it work, they had to come and buy a London-based startup. So Moixa, who was a company in London that we had dealings with some years ago, they built all of the software back end on how to control all these batteries and make them work. They scaled that up through Japan, where they had 50,000 different homes under the control of their Moixa software, and now they've just been bought out by Luna. So they're now integrating in with this hardware stack that is developing the batteries. And so it's this integration of hardware and software built into, in this case, domestic buildings, but also residential and commercial buildings, and the coordination, all of that, which is really the direction of travel for so much of the sector at the moment. Next slide. Thanks, Cliff. So just to kind of put this in some international context, really recently, Australia has just been told that everybody in Australia is going to get 3 hours of free electricity every day. So this is because they got so much solar on their rooftops that if all of that solar basically is exported into the electricity network, it creates a problem for the network. So by telling people that they'll get a guaranteed 3 hours of free electricity when the sun's shining the most, people are now just madly buying up batteries and putting them into their homes. So what that does is it allows it to absorb all of that solar energy from the PV into the battery, and they can then sell that later back to the grid for a profit, and then they can charge up their batteries whether or not they've got solar from the grid when it's free. So this is what's happening. This is Australia as a leader, but in the European context, the Netherlands also have a critical problem with too much rooftop solar. And if you jump down one slide, Cliff, just literally yesterday, the UK government is allowing what's called plug-in solar. So you mightn't have come across this, but particularly in the German market, you can go to your local DIY, hardware shop, and you can buy a solar panel and you can bolt it onto your balcony and you can plug it into any electricity socket in your home. And then that power from that PV runs straight into your home network and powers anything that's running, your fridge, your dishwasher, anything that's running at the time. So now the UK government has done that. In Germany, they've actually added over a gigawatt of power, which is, to put it in context, that's the same as sort of several really large central power stations. And this has happened incredibly quickly, partly because we've got so much cheap solar coming out of China now that we can plug that into the system. Again, just for context, I think last year in Pakistan, they imported over 20 gigawatts of solar into the Pakistani system, which added about sort of 50% to the electricity capacity on their system. And people are just doing it. They don't need permission. They just go and buy this stuff because it's the cheapest stuff you can buy to power your homes. And it's going to happen in markets all across both the developed and developing world. And this is a really big thing to try and work out how to manage and integrate into our buildings. Next slide, please. So, Cliff touched on this, but basically what we're doing is, we used to have all these big central power stations. We still have quite a lot of them. But what's happening now is that basically as solar and wind and electric vehicles and heat pumps are getting cheaper and cheaper, we're moving to having these all the way through our built environment. And that company I mentioned at the start, Luna, they're building out this tech and installing it. And then what you need to do is to be able to control all this stuff. And that's where it gets complicated. And that's the kind of work that we are really heavily involved with. And I'll talk a bit about that now. So we jump down one more, Cliff. So where we think this is going, and we've got pretty good reasons for believing this is the case, is soon your personal AI agent, which you're using, many of you will have used ChatGPT, or I use one from Anthropic called Claude. That is the thing that's going to manage your energy resources. And so effectively, it will be trying to work out when to charge and discharge your electric vehicle. It will be looking at your calendar on your phone and knowing when you need to go and drive somewhere, whether you'll be home this weekend or away. It will control your heat pump. It will be charging and discharging your battery. This is fundamentally transformative for the entire energy system. But we're working on this, and we know people across the US. I've got colleagues in the US, in Switzerland. Private sector companies are working on this at the moment. And this is something that will really change the way energy is managed. Well, we think we need to really understand this because it could potentially have a really big impact. So what we're exploring is what this means. If we jump down one more, Cliff. So to understand this, you have to kind of think about how the energy system is managed. And this is a lot to do with the structure of the course that we teach. So effectively, down the bottom, you've got a whole lot of physics. You've got bits of physical hardware. You've got batteries, transformers. You've got your electric vehicles, your heat pumps, and you've got power flowing in and out of all of these every second of the day. Sitting on top of that, you've got a whole bunch of Internet of Things and devices that are controlling the flow of that power. They're also trying to work out how much you will need and when. So they're trying to forecast load, and they're trying to manage that in relation to each other so we don't all charge our electric vehicles at the same time. And sitting on top of that, you've got a whole lot of financial flows and monetary flows of who pays who for using their electricity at what times of day. Interestingly, in India, now I think one of the most populous, I think it's now the most populous country in the world. Basically, they have just this January, it's under consultation, got a national scheme to allow people to trade energy through what's called peer-to-peer. So this would allow people to trade energy between their neighbors as opposed to having to buy it from centralized energy systems. If this goes through, it's going to be transformative to the way the developing world operates. It's a bit like introducing mobile phones where people can exchange data and messages directly between each other rather than having some kind of centralized communication system. So this is the way things are being driven at the moment. Next slide, please, Cliff. So what we're doing is we're building out test beds to explore with people how this is going to work in their community. So what we're trying to do is to work out, once we start getting these AI systems to manage all of our devices, what does that mean for communities that we're operating in? How does that community want to prioritize what it does with its energy and how it shares its energy? Do they want to try and just make as much money each as possible? Do they want to try and save carbon? Do they want to help those people who are less well off within the community? Do they want to share energy between schools and homes or hospitals and businesses? All of that technology is now becoming possible within the system, and we're building out a test bed for that. Next slide. So just to give you a sense of how quickly this stuff is moving. So this is work we're doing literally at the moment. This was a briefing we gave to DeepMind. So DeepMind is part of Google, and Google have built out their own set of the Gemini LLM systems. We were talking with DeepMind. Worth pointing out, DeepMind is a few hundred meters from the building I'm sitting in now at UCL. This is what makes being physically in London so interesting. We have the Knowledge Quarter, we have DeepMind, we have some of the best information technology startup ecosystems anywhere outside of Silicon Valley. So we were talking directly with them. They're super excited about this work. A bunch of us all across UCL are involved in this. A lot of these are in the team that will be teaching you. Jump down one more, Cliff. So we're using DeepMind's Concordia platform. This has been developed specifically for seeing how agents can cooperate with each other. We were presenting to Sasha, one of the senior technologists in DeepMind, along with a couple of his colleagues. And they were basically saying, we're all in. This sounds super interesting. Let's write papers together. Let's work together. We think this is a great application for this DeepMind technology. Next slide. So what we're building out is this Concordia platform. And what it does is the AI agent talks to the person, the homeowner, and asks it how the agent should act on the homeowner's behalf, when it wants the electric vehicle charged, what its priorities are, how it should act. And then after we've trained those agents, then they work together and they work in this Concordia platform, and they can reach out and collect data from external sources about weather and carbon intensity and grid loading. And they can run a simulation about how much constraints there are on the network. And they can negotiate with each other about how they can share resources and make sure they don't overload the network. Next slide. Thanks, Cliff. So this is literally something that nobody has seen outside of the immediate team. So not even DeepMind have seen these slides, but these are slides that we produced 2 days ago from the team, kind of showing the effect of having these agents talk to each other. So what you're looking at here is down the bottom in that blue color is the kind of all the loads in your home that are going on in the background, your fridge, all the things that just constantly tick over. Then that big green block in the middle is an electric vehicle. And this is how it would charge if you just left it to its own devices and just said, charge whenever you want to charge. And basically the model is replicating that kind of behavior if we tell the agents not to talk to each other. But if we go down one more, Cliff, then once we tell the agents they can talk with each other, then you see that orange line that goes through, basically the agents can work out how to shift their load between them so that they stay underneath that dotted red line. And that's super important because that means they stay within the capacity of the network. So we've got students, CB dissertation students. So I've got 3 master's students who are all working directly on this, helping us build it out. They'll be improving the modeling. We'll be talking with policymakers. We'll be talking with DeepMind, presenting, writing papers. And this is the kind of world you're going to be thrown into the middle of if you come and do this course. And you'll be getting stuff that nobody else in the world has seen before. So that's kind of where you're going to land if you come and jump in the course with us. So I think that's all from me. Oh, I think there's one more. Yeah, thanks, Cliff. So what we're also doing is we're going to stitch this back into models that colleagues have made. So Pamela Fennell on the course, who runs our urban building simulation model, we're going to be linking our AI agents into her models so we can start to look at this all across areas of London. This is what we're doing with, we're bidding in for work with the Greater London Authority. We're working with the Digital Catapult and lots of startups. So again, we're stitching together all of this technology that's been built out for the government in the UK with public and private sector money to build tools that we can use to really understand how the system's changing. Right, that's it from me. Thanks, Cliff.
Thanks, David. I'm going to leave it with this slide open so that if anybody wants to scan the QR codes, you can. And what I cannot see is if there are any questions because I have the presentation screen up. So do we have questions to answer? Perhaps while we're checking that out, let me just ask Varun to come in and tell us you graduated a year ago, is that correct? And tell us what you're doing now.
Yeah, and, 2 years ago.
2 years ago, it can't be that long.
Even I thought the same thing, but yeah, no, it is quite long. Yeah. So at the moment, I'm currently working for a SaaS company under the BMS field. So what I do is at the moment, I take care of the refrigeration and the HVAC side of the building management systems for one of the clients, the retail clients. So we have multiple sites across all over the UK. So what I do is like any critical system failure happens in any of those refrigeration or HVAC systems, or my team is the first person in contact to get those things resolved in. So the reason for me to go into is this: I had an engineering background, and I really wanted to get a little bit more deeper understanding on how the commercial buildings basically consumes electricity. Just wanted to see it from the first-hand point of view.
That's great. Thanks, Varun. We'll come back to this if there's time. I'd like to ask you more about your role and the transition from the MSc into it. Can I ask Hallie? Can I ask you to tell us a little bit about what you did before you joined us and how you're finding the course so far? I guess we are in the last week of term 2 at the moment, so. Thank you very much for coming, Hallie, when you have a huge amount of coursework just waiting for you.
I do. Happy to be here. Yeah, I graduated. I'm from California originally. I graduated from university with a degree in environmental science and a minor in political science. Worked for a couple of years still in California. So I spent about 8 months with the state government doing a lot of public policy there. It was more broad. I was thinking of going into environmental policy. And so that's why I spent a bit of time with the state government. And then after that, I moved into the startup world, which is completely the opposite of the public sector. And also a very different discipline. I was working more in business development for food waste valorization. And then I was I was trying to figure out where I wanted to go after that. I knew I always wanted to do a postgraduate degree and had always wanted to move into the energy field. And so I applied to come abroad to UCL, and now here I am. And in terms of the program, I would say it's honestly impressed me from the get-go. If you are looking for an interdisciplinary, multidisciplinary world, this is very much it. You get a really great faculty and teaching team who have a range of backgrounds related to smart energy in the built environment, and they have crafted a really great curriculum. So term one with the core modules, and Cliff had touched on this in the presentation, really gives you a solid foundation from the physics and modeling piece of it all the way up to kind of the social and political context. And I think the worst thing about it is how challenging it is. But it's really great, and you're going to feel the growing pains, especially because there's going to be a lot of backgrounds in your cohort, and so some people are going to be really great at some aspects, and you're going to be better at others. But it's really wonderful to have that spread of professionals next to you. And my cohort, at least, we have a great size. Everyone has been really supportive of each other. The teaching team is incredibly supportive academically and in terms of our well-being. And like I said, even though it is challenging, and yes, last week of term 2, and I have a lot of coursework, but it's very, very rewarding.
Great, thanks, Hallie. Yes, you're on about as busy as students ever get. So yes, it's right at peak time at the moment. You did say something I wanted to highlight actually to those thinking about joining us, is that the vast majority of people on our program have no background in energy. Some have backgrounds in buildings, but certainly not all. And so we're really looking for people who can apply what they know from their diverse backgrounds and apply it to our sector and learn from the materials that we provide and take it further. I'm going to stop sharing the links.